today we will discuss on the topic gas laws. So the gas law, the first gas law we will discuss is Boyle's law. And this Boyle's law gives us the relationship between pressure and volume. So the learning objectives for today's topics are the definition of the Boyle's law. Then we will discuss on expressing the relationship between pressure and volume, which is actually explained by Boyle's law. Then after that, we will also look to how to derive Boyle's law and the formula that we are going to get it from the Boyle's law. And the last learning objective is the numerical problem solving or the problem practice. So with these four learning objectives, we will be able to understand Boyle's law. So here are some key points that we have to bear in mind. The first one is the units. The units that we will be using for pressure, volume, and temperature. So more detail on the units, I would like to request all of you to refer page number from your textbook, page number 1 to 2. So there you will see the units for pressure, volume, and temperature. For example, we have for pressure, most of the time we'll be using ATM, and we will be also using millimeter mercury. For volume, we'll be using liter, milliliter, as well as centimeter cube. And for temperature, we'll be using Kelvin, and sometimes it's expressed in degree Celsius. So this is the first point that we have to keep in mind when it comes to unit. Then the second point is pressure of the gas. And the second point is the relationship between pressure and volume. So according to the Boyle's law, we will find that the pressure behaves inversely proportional to volume, or pressure is inversely proportional to volume. So that means when the pressure increases, volume is going to decrease. Likewise, when the pressure decreases, volume will increase. So this is what we call it indirect relationship or inversely proportional. So this relationship we would be able to observe only when the temperature is kept constant. So constant here means same throughout the experiment. So we can take an example of the place, the temperature for the place. So in the morning, if the temperature of the particular place, if it is 25 degrees Celsius in the morning, even is going to remain same during night time. So such kind of example, we call it constant. So pressure of the gas have inverse relationship with the volume when the temperature is kept constant. So Boyle's law, as we have already seen, indirect relationship of pressure with volume when the temperature is kept constant. So we can state that at constant temperature, volume of the gas is inversely proportional to pressure. So if we repeat it again, when the volume increases, the pressure of the gas decreases, and when the volume decreases, the pressure of the gases will increase. So this is what the Boyle's law states. At constant temperature, the volume of the gas is inversely proportional to pressure. Inversely proportional to pressure. So inverse means indirect. Now we have learned that according to Boyle's law, we get to know this expression that pressure of the gas is inversely proportional to volume. We can also express this expression like where volume have an inverse relationship with the pressure. Now, in order to remove the proportional sign, we can multiply this value with a constant K. So volume, by removing the proportional sign, we can replace it with equal sign when we multiply 1 by P into K. So in this way, we will be removing the proportional sign by multiplying it with K. Now to rearrange the equation, we'll send this P to the other side. So P here is in the denominator. So when it changes sign, it will go to numerator. So it becomes PV is equal to K. So this is our Boyle's law formula. So now let us discuss the mathematical expression of Boyle's law, and also let us try to derive the equation for Boyle's law. So in this case, we'll try to imagine two cases. So in the first case, let us imagine that we have a piston. We have a piston, and that piston contains gas. So let us imagine that this gas exerts some pressure, and let us denote it with P1, and the volume of the gas as V1. So in this first case, we will consider it as the initial state. So initial state, the volume of the gas is V1, the pressure of the gas is P1. And in the second case, let us call it final state. So the same piston, let us assume that we have gas here. So from the initial state to the final state, let us say that the pressure got increased. That's why the piston got moved down, and also the volume got decreased. So let us call the pressure of the gas as P2 and the change in the volume as V2. So once again, in initial state, we have volume as V1, pressure as P1. And in the final state, when the pressure got increased, the volume decreased. So that is what we call it Boyle's law, because volume and pressure, they are inversely proportional. So pressure increased, the volume got decreased. So now in the final state, we have pressure P2 and volume V2. So keeping that in mind, let's try to apply the Boyle's law expression to derive the equation. So initially, from the Boyle's law, we got this expression where volume is inversely proportional to pressure. To remove the proportional by multiplying the right hand side with a constant K, we got this expression PB is equal to K. So now let us apply this expression to the initial state and also this expression to our final state. So when we apply this expression to the initial state, our pressure is P1 and our volume is V1. So we will write it as P1 V1 is equal to K. And when we express this expression for our final state, our pressure will become P2, volume will become V2. So P2 V2 is equal to K. And we have already learned that this K is our proportionality constant. And we also know this, the K here, they are constant and they are equal. So we can also write K is equal to this K is equal to this K. So to express, so we can also replace this value with P1 V1 and this another K value with P2 V2. So we can also write it as P1 V1 is equal to P2 V2. So this is our Boyle's law equation. So Boyle's law equation, we have P1 V1 is equal to P2 V2. So now let us discuss the questions. So this will be our activity 1.1, whereby we will try to solve some of the solved problems together. So for this, I want you to refer practice problem from your textbook, page number 4, question 1, page number 4, question 1. It states that a sample of helium occupies a volume of 160 centimeter cube at 10 atm, so that is pressure, and 25 degrees Celsius. What volume will it occupy? So the question is asking you to calculate volume. What volume will it occupy if the pressure is decreased to 8 atm at a constant temperature? So the question gives us the clue or the hint that the initial volume was 160, initial pressure was 10 atm, and then it asks us to calculate the volume if the pressure decreases from 10 atm to 8 atm. So hence we can write it, this pressure as P2 and the question as V2. So from the Boyle's law equation, we learned that P1 V1 is equal to P2 V2. So by using this formula, we have to solve this question. So now we are asked to calculate V2. So the first step is rearranging the equation. This equation, we can also write it as P2 V2 is equal to P1 V1. Now since we are asked to calculate the V2, so we will send P2 to the other side. So P2 is in the numerator. When we send it to the other side, it will go to denominator. So let me rewrite this same equation here. P2 V2 is equal to P1 V1. So keeping the V2 on the left hand side and sending the P2 to the other side, so P2 will go to denominator. Now we can substitute all this value to this equation. So V2 is equal to, so the P1 here is 10 atm into V1 is 160 and the P2 here is 8. So 160 into 10, we get it 1600. Divide by 8, we get it 200. So our final volume is V2 is 200 and the unit here is centimeter cube. Activity 1.2. So this will be assigned to you as your homework. So I want all of you to solve question number 4 from page number 6. So you will find question number 4 from page number 6. I want you to refer it and solve it as your homework. So to recapitulate, we have learned what is called Boyle's law, and that is the relationship between pressure and volume. We have also learned about how to express the relationship between pressure and volume. We have also derived Boyle's law, the formula, and the equation, and we have also solved numerical problems. So with this, we are done with first lesson.